wasn't going to do a second example of example 6, but this is pretty hefty. So we'll do another one, example 6b. Okay. Same setup as before. Let's do g of x is 4 over x plus 2. And the same questions that I'm going to work with, or that we worked with in the last example. First thing we want to do, let's find g inverse of x. I'll call this part A. Find g inverse of x. So again, first thing, switch our x and our y around. We get x equals 4 over y plus 2. And I don't like that I have this fraction here. Multiply both sides by y plus 2. Divide by x. And then subtract 2 from both sides. So 4 over x minus 2 is my inverse. Part B, let's do g composed with g inverse of 0. So this one, g inverse of 0 is where we start. If I take 0 and plug it into my inverse, what happens? I'd have 4 divided by 0. That's undefined. Okay. So again here, we see the same situation we saw in example 6a. In theory, our function and its inverse, they're both functions, they're one-to-one. This composition should give me just 0, but that value for 0 has to be defined in both functions as well. So 0, I can plug it into my original, but if I take 0 and plug it into the inverse, 4 divided by 0, I can't do. All right. So I guess something else that you could check too is think about what your domain and range are for both of these. So there is a value for x that would cause a problem. X cannot be negative 2 in my original function. So that's our clue that the inverse would have some kind of restricted domain also. But in this case, x can't be 0. And when you have that kind of restricted domain, this composition isn't always going to work out nicely. Part C will work out nicely if I do g inverse composed with g of 0. We start off with g of 0. If I take 0 and plug it in here, 4 over zero plus 2. 4 over 2 is 2. Take that, plug it into our inverse. 4 over 2 is 2, minus 2 is 0. Okay, again, you also could have kind of taken a shortcut. We know this one doesn't work, this one will work, and we should get 0.